Welcome back, focused learners. So glad you're joining us for another deep dive. Today, we're unpacking Chapter 3, Precision Farming. If you've ever wondered how modern agriculture is totally ditching blind guesswork for exact data-driven science, well, this is the explainer for you. Over the next few minutes, we're going to journey together through the whole life cycle of building your very own smart farm, from the very first planting stages all the way to a perfectly timed harvest. All right, let's get right into it. Here's our roadmap for this explainer. First, what exactly is precision farming? Then, planning the smart farm, diving into DIY tech and automation, exploring soil health and biofertilizers, and finally, time for the harvest. Section 1. What is precision farming? The science of agriculture. Take a look at this incredible drone-captured health map. Instead of physically walking massive fields and just kind of guessing, farmers are now using remote sensing, like satellites or drone imagery, to get a literal, color-coded map of crop health. See those red squares? They indicate poor health, making up about 17% of this particular field. The green squares, just 1% here, show the thriving crops. By looking at this exact data, farmers can pinpoint precisely where they need to jump in with irrigation, fertilizer, or pest management. No more wasting resources spraying the entire field. So that brings us to the core definition of precision farming. It's essentially using science and technology to give plants exactly what they need: water, nutrients, care, at the right time and in the right amount. The word precision here is key. It means exactly as required consistently every single time. It's the Goldilocks zone for plants. Not too much, not too little, just right. The perfect amount of water, the precise blend of nutrients, delivered at the exact perfect moment. We're totally replacing those old habits of blind guessing. This is a massive shift, and it completely changes how we grow food. On one side, you have traditional farming, where, let's face it, you're pretty much at the mercy of the weather. But on the flip side, with precision farming, you have precise control over temperature, humidity, and light intensity. How? By using structures like greenhouses or shade nets and tapping into meteorological forecast data. You're basically building a custom, fully optimized VIP lounge for your plants to thrive in. Section 2. Planning the smart farm. The steps before planting. Now, this empowering DIY planning phase really boils down to 3 crucial steps. Step 1. Check the agroclimate compatibility. You've got to make sure the life cycle of the plants you choose actually fits your local climate. Step 2. Decide community usefulness. Are you growing veggies for a school midday meal or maybe flowers for an upcoming festival? Basically, grow what's useful. And step 3. Site selection. You need a level area with good ventilation, a reliable water source, and proper sunlight. Because without these 3 foundational pillars, even the best tech in the world won't save your crops. Once you've nailed down your location, it's time to get organized. The chapter actually highlights a fantastic caselet of grade 9 students from a government high school who did exactly this. They created a super structured process chart to manage their smart farm project, breaking down a massive project into specific tasks like, site selection, setting up a humidity chamber, installing drip irrigation, and clearly assigning who does what. That turns a totally daunting challenge into highly manageable chunks. Section 3. DIY tech and automation, making precision possible. So think about this fundamental question for a second. How do we actually give plants exactly what they need without wasting a single drop of water? In traditional farming, a ton of water just evaporates or runs off into the soil where roots can't even reach it. So how do we fix that? Well, the answer lies in automated DIY drip irrigation. Look closely at how these components interact. We've got an Arduino microprocessor acting as the brain of the whole operation. It's connected to a soil moisture sensor, those 2 golden prongs on the left, that you literally stick right into the dirt. Now, instead of watering on some rigid, arbitrary schedule, this sensor constantly reads the actual moisture level of the soil. When it detects that the soil is genuinely dry, the microprocessor signals a relay, which then triggers the water pump to deliver water directly to the roots. And the second the soil has enough moisture, it shuts right off. That, my friends, is true automated precision. But hey, soil moisture isn't the only thing we want to track, right? We can also build DIY weather monitors. Using similar, really simple sensors and programming boards, you can record the exact temperature and humidity inside your growing chamber or greenhouse. This gives you absolute, real-time visibility into the exact climate conditions your plants are experiencing. So if things get too hot, you know exactly when to vent the greenhouse or add some shade. Section 4. Soil health and biofertilizers. The biology underground. Okay, you'll definitely want to remember this brilliant efficiency hack, fertigation. In precision farming, managing soil nutrients is absolutely not about indiscriminately spraying chemicals everywhere. Instead, fertigation combines your fertilization with your drip irrigation system. It allows for the highly precise measurement and supply of essential plant nutrients directly through the water lines, right to the root zone, where the plant can soak it up immediately. You're literally using your existing water tech setup to deliver the food. How cool is that? And underground, there is absolute biological warfare happening. Those grade 9 students we mentioned earlier learned about an incredible biofertilizer called trichoderma. It's a type of fungus with literal superpowers. It lives right on the surface of plant roots and actively helps the plant absorb essential nutrients, like phosphorus. But wait, it's also a bodyguard. It releases lytic enzymes that dissolve the cell walls of harmful fungi, and it releases natural toxins to kill pathogens. By introducing this good fungus to your smart farm, you're organically protecting your crops without needing any harsh chemical pesticides. Section 5. Time for the harvest. Reaping the rewards. Of course, all the high-tech precision in the world doesn't mean a thing if you drop the ball at the very end. Timely harvesting is absolutely critical. Collecting your produce at the exact right moment ensures better quality, optimal taste, and a much longer shelf life. If you delay even a little bit, the produce can become overripe, lose that carefully cultivated flavor, or just spoil quickly. The precision has to continue right up to the very second that vegetable leaves the stem. And that brings us to the end of our journey today. I want to leave you with this final, thought-provoking question. With just a few simple sensors, some inexpensive microprocessors, and some helpful fungi, how could these precision skills reshape the future of food in your own community? You really don't need a massive commercial farm to utilize these concepts. The tools of precision farming are accessible, they're DIY friendly, and they are ready to be implemented in your local school, rooftop, or backyard right now. Thank you so much for joining me on this Explainer Focused Learners. Keep exploring, keep planning, and I'll see you next time.